Welcome to Fascinating Frontiers, episode 100. Today is June 13th, 2026. Let's look at what's new across the frontiers of space and science. That's episode 100, a big milestone. Thank you for being here. NASA's X-59 jet just broke the sound barrier for the first time while aiming to replace thunderous sonic booms with a quiet thump. The experimental aircraft reached Mach 1 while engineers measured the resulting pressure signature on the ground. NASA designed the long, slender shape to reshape the shock waves into a softer thump rather than a loud boom. This milestone advances the agency's goal of enabling supersonic flight over land without disturbing communities. Follow-on flights will refine the acoustic data before any potential regulatory changes. The long, slender fuselage was chosen specifically to control how pressure waves propagate to the surface. A record-breaking quasar that existed 12.9 billion years ago already hosted a black hole of enormous mass. Its spectrum shows rapid accretion despite the limited time available after the Big Bang. Spectra already show the surrounding gas as being pushed outward at high speeds. The record-breaking quasar offers a rare window into how supermassive black holes assembled when the universe was less than 1 billion years old. Its extreme luminosity and rapid growth imply seed masses or accretion rates that current models struggle to produce. Follow-up observations with larger telescopes will search for similar objects at even greater distances. Next, larger surveys will hunt for more examples at comparable distances to test whether this object was typical or an outlier. Now shifting to a modern engineering effort reshaping flight over Earth. The experimental X-59 aircraft reached Mach 1 while engineers measured the resulting pressure signature on the ground. NASA designed the long, slender shape to reshape the shock waves into a softer thump rather than a loud boom. This milestone advances the agency's goal of enabling supersonic flight over land without disturbing communities. Follow-on flights will refine the acoustic data before any potential regulatory changes. Ground sensors captured detailed pressure data during the initial supersonic run. While engineers quiet the skies, another crew prepares for a far noisier descent near the lunar south pole. The 4-person Artemis 3 crew discusses how test flying experience prepares them for the complexities of landing near the lunar south pole. The episode of Houston, We Have a Podcast captures their reactions to receiving the assignment through an unexpected HR meeting format. Listeners hear directly about the training timeline leading to the first crewed lunar landing since 1972. The discussion highlights coordination between Orion, the human landing system, and gateway elements still in development. The crew described how their prior test flight backgrounds directly inform decisions about descent trajectories and hazard avoidance near the South Pole. As Artemis crews train for the Moon, a routine cargo mission is already heading home from low Earth orbit. The uncrewed SpaceX Dragon will depart the International Space Station, carrying completed experiments and station hardware. NASA will provide live coverage of the undocking and splashdown sequence. The 34th SpaceX resupply mission marks another routine cargo return in the ongoing commercial resupply cadence. Watch windows open next Tuesday with real-time updates from Mission Control. The spacecraft is expected to return a variety of scientific samples collected during its time berthed at the station. While Dragon heads for the Pacific, we look back to the first craft that left the solar system entirely. On June 13, 1983, the Pioneer 10 spacecraft became the first to leave the solar system on an escape trajectory. It had already achieved the first flybys of Jupiter and the asteroid belt, plus the first crossing beyond Mars. Radio contact continued until 2003, after which the probe continued outward at roughly 12 kilometers per second. Its plaque remains the first physical message sent toward potential interstellar recipients. The spacecraft's trajectory took it through previously unexplored regions of the outer solar system before it crossed the heliopause. From the edge of the solar system, we turned to a swarm concept that could tag many asteroids at once. The white paper outlines a fleet of small satellites that would rendezvous with multiple near-Earth objects and attach tracking beacons. Remote sensing alone cannot determine internal composition, so the probes would provide direct surface and subsurface measurements. The concept was submitted to the UK Space Agency's 2035 Space Frontiers program. Multiple targets could be visited with far lower mass than a single large spacecraft. The Remora approach would allow repeated close contact measurements across a range of asteroid types. From tagging asteroids, we moved to a rover that literally changed shape on the moon. The autonomous sphere rolled across the surface before unfolding into a wheeled robot for closer inspection. It operated for a short period in 2024, demonstrating shape-shifting mobility without human intervention. The design addressed the challenge of traversing both flat plains and small craters with one platform. Engineers are now evaluating similar concepts for future lunar and asteroid missions. The Japanese rover's transformation sequence was completed autonomously after touchdown on the lunar surface. After lunar mobility, Japan's flagship rocket has also returned to reliable service. Japan's new flagship vehicle lifted off from Tanegashima, carrying 6 satellites after last year's payload loss. The flight demonstrated reliable performance of the main engines and upper stage. Recovery of the launch cadence supports Japan's plans for both government and commercial payloads. Additional missions are scheduled to restore full operational confidence in the system. The successful H3 flight marks a return to operational status following the previous mission's anomaly. Reliable launches matter for national programs, including Canada's growing sovereign capabilities. The Canadian firm has secured additional contracts supporting national satellite and exploration programs. Work includes contributions to communications and Earth observation systems that reduce reliance on foreign providers. The contracts align with long-term goals for independent access to space data and technology. Domestic industry capacity is expected to grow through these sustained commitments. MDA Space's expanded role supports multiple ongoing Canadian government initiatives in orbit. While Canada strengthens its space sector, a bright comet offers an easy target for backyard telescopes. The comet recently jumped from 18th to much brighter magnitude while moving through southern Pisces. Observers with modest telescopes can locate it near Saturn in the morning sky. Outbursts like this are thought to result from sudden exposure of fresh ice on the nucleus. Continued monitoring will show whether the increased activity persists through the coming weeks. Comet 220P McNaught remains visible in the pre-dawn sky for observers at southern latitudes. From a fleeting comet, we shift to a month-long record of 2 bright planets. The 2 planets appear to draw nearer in Earth's sky even as their actual orbital distances increased. The composite image captures the changing angular separation night after night from a single observing site. Such alignments occur regularly, but rarely receive this level of continuous documentation. Observers can still catch the pair low in the west after sunset this month. The 30-day collage of Venus and Jupiter was assembled from images taken at the same location each evening. While planets dance in Earth's sky, another mission invites the public to ride along. Participants can submit their names to fly aboard the upcoming infrared observatory, designed to survey wide areas of the sky. The mission will measure distances to millions of galaxies and search for planets in the Milky Way using microlensing. A digital boarding pass is available now through the dedicated NASA portal. Data from Roman is expected to complement narrower field observations from other telescopes. The Nancy Grace Roman Space Telescope name collection effort allows public participation ahead of the observatory's launch. As names head to space, some proposed satellites could complicate the view from the ground. Proposed constellations of data processing satellites would add bright, moving sources across wide sky fields. Ground-based telescopes already contend with increasing numbers of low Earth orbit objects during long exposures. The concern centers on both direct glare and scattered light that could compromise faint object surveys. Operators and astronomers are beginning discussions on mitigation strategies before the first launches. The proposed orbital data centers would introduce new sources of both point source glare and diffuse scattered light. From sky interference, we turn to corporate changes that may affect NASA partnerships. The company's valuation now reflects investor interest in artificial intelligence applications alongside launch services. NASA must navigate how a publicly traded partner balances shareholder expectations with government mission priorities. Existing contracts for crew and cargo remain in place, yet future negotiations may incorporate different financial oversight. Industry analysts are watching whether the new structure affects bidding on lunar and Mars architecture work. SpaceX's public listing introduces new variables into long-term planning for agency programs. Finally, a quiet chemical clue is rewriting how we think life's ingredients arrived on Earth. Iron meteorites and chondrites show phosphorus to nitrogen ratios that challenge earlier models of how Earth acquired these elements. The work points to Jupiter's early migration as a key distributor of material across the young solar system. Samples from different formation regions reveal distinct chemical fingerprints preserved since the protoplanetary disk era. Further laboratory analysis of additional meteorites is planned to test the revised timeline. Iron meteorites that formed closer to the Sun carry one phosphorus to nitrogen signature, while younger chondrites record a distinctly different ratio after Jupiter's migration stirred the inventory. The difference is measurable down to parts per million, revealing exactly when and where the ingredients for oceans and biology were delivered. Yet the precise timing of Jupiter's first inward then outward journey remains an open question that no current sample set can fully pin down. New chapters in solar system history keep unfolding from the smallest chemical clues. Next time, we'll be watching for updates on the Dragon splashdown coverage and any new details from the Roman telescope name submissions. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow, and if you'd rather watch than listen, find us on YouTube at NARA Network, links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give Tesla Shorts Time a listen, your daily deep dive into everything Tesla. You can explore the whole lineup at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.